but to get the hold on the data engineering part, these things are really required. So let me just share my screen and let me know once you are able to see this. Can you see my screen?
Yes.
Okay. So show me first. Okay. So first we'll try to understand what is big data. So what is your understanding on big data? Like, what do you understand by big data? If you have to, let's say somebody is asking, like, what do you understand by big data? So what is the first picture that comes to your mind?
Millions of row and columns.
Okay. So basically data, right? Data which is there in the form of a row and table, row and columns, right? So basically you are talking about the table. Yes. So table is like, okay, whatever data we are having as a in the form of table, that is basically structured data, right? And mostly our traditional systems used to process only structured data sets, which is there in the form of a row and columns, means table, or it's going to be an Excel file, or XML file. So basically structured and some sort of semi-structured data that we can handle through our traditional systems. But when we talk about big data, so here we are talking if I talk about the volume in terms of terabytes and petabytes, so huge amount of data. And when we are going to process this data from the traditional systems, like on traditional systems, like we have got Oracle, Teradata, Exadata. So they have got their some sort of capacity with themselves. Like after this point of time, their capacity expires, and they say they are not able to process that huge amount of data. But still, it's not about only the the size of the data. Here we are going to talk about the complexity of the data. Complexity in the terms, like it's not only huge, but it's complex in the sense that it's we are having different formats of data. Like we are having structured, semi-structured, unstructured data. So when it comes to unstructured data, like audio files, video files, images, and human text, human readable text. So when this kind of data comes, so basically our traditional systems becomes incapable of handling this kind of and this volume of data. So that's why when we coined this term big data, it was basically the collection of data so large and complex that it becomes difficult to process using on-hand database management tools. Means traditional systems or traditional applications, it was not in their hands to process such huge amount of data and complex data. So the major challenges mainly at that point of time they were facing was how we are going to capture it, how we are going to curate, storage, searching, transfer, and if we are not able to do, then how we are going to do the analysis and visualization on top of it. So these were the the main issues. So basically big data is the problem statement. It's when the data was growing so large and so complex, so it becomes a problem to the ongoing database systems, that they were not in a position to handle such huge amount of data. So this was a problem statement, right? Now when it comes to like big data, from where we are getting this data. So basically there are multiple there are a number of sources from where we are generating this data. Like it's coming from, let's say, Amazon. Basically we can say it's an ERP system from where we are generating huge amount of data, because whenever you are going to any of the ERP systems, so wherever if you click on any of the links, so basically it generates on each click, it captures the customer data. So more than 100 million uh, user clicks are getting done in on Amazon itself. Apart from this, we have got eBay is there. We have got Flipkart. If I'm just going to talk about few of them. Apart from this, we have got like social medias are nowadays, like Twitter is there, like X now, and then we have got Facebook, we have got YouTube, Instagram, and many more social media platforms where people are posting their posting their messages, their images, their videos, and nowadays even a lot of people's who are handling their businesses from home itself. They are creating their live videos. They are sending their videos. So a lot of data is getting generated on daily basis. Same it's going for the stock market. So stock market generate more than this is very per day basis more than terabytes, and even now it's going to be in petabytes of data on daily basis. And if we talk about like emails are getting sent, so huge number of emails are getting exchanged between different organizations or between the users itself. So they are generating huge amount of data. Apart from this, we have got now IoTs are there. Now AI is getting generated. Now everybody is having mobile phones with them. So if they have got the internet, so everyone now is generating a huge amount of data. So they are like wherever you see, you will see a lot of the sources of how we are generating this huge amount of data. Let's say if I'm talking about, let's say if you are traveling by your own car and you have used the GPS, so you are also generating huge amount of data within a just single one flight, like say half an hour or 1 hour flight. One flight generates more than 1 terabyte of data from different sensors. So one plane have mostly around 600 plus different sensors are there which are capturing different forms of data within this black box itself, so that each and every seconds what is happening with the plane, what is the situation going on within the plane itself, so that generates that huge amount of data. So in this way we are generating huge amount of data every time, right? So this was some experiment done. It's quite old, but yeah, if you talk about 2016 to 26 itself, it's a huge. So basically, there was an organization called IDC. So they have done some sort of uh, analysis on top of it, and they find they have just given the each number that okay, by 2020 the data will reach to 40,000 exabytes or 40 zettabytes of data. But in 2020, this this number was not 40 zettabytes; it was around 60 zettabytes. And they were thinking that as per the the trend is going and the data is exploding exponentially, it's increasing. So they have come up with the this approach that okay, by every 2 years the data is getting double. So by 2020 they have given this prediction that around 5.2 TBs of everybody is having around this 5 terabytes of data. This was an average on that, but now if you see it's going to be more than that because with the introduction of this AI itself, and also from this social media platforms, the data is increasing very at a very higher pace than it was expected, right? And one more thing, yes, like whenever you feel okay, you are exhausted or uh, you are not getting the point clearly, just stop me there itself and try and ask me to explain, right?
Yes, yes.
Yeah. So because what we are going to do it here to for the first two sessions, we are a little bit faster, little bit. But these are
Okay.
as these are going to be the concept itself. So maybe if you don't understand anyone, just let me know, right?
Yes, yes.
Okay, so at that point of time, then when this huge amount of data was getting generated and big data was flourishing at that point of time, so IBM has given some definition of big data. So initially they have given this big data in terms of three V's, that is volume, velocity, and variety. So volume, as you see, as the time is passing, like if we are going to if we are just putting the time as constant. So every 1 hour, my data, let's say, is getting increased, or on daily basis, my data is getting, increased. The volume is getting increased day by day of the data. So if the data is, basically increasing on daily basis, so definitely it's velocity. It means that speed at which we are getting this data and processing the data, that also needs to be, increased, because if my data generation speed is increasing, so if we are not processing it on the same pace, so definitely we are going to lose the track, right? So volume, velocity. Third was the variety. So the data that we are getting as a part of big data, it was not structured data, as you have mentioned, like as I asked you, like what do you mean by big data? So you told like it's going to be in the form of row and table, so row and column. So basically that a tabular data, but that is not the the huge amount of data that we are generating. Mainly the data that we are generating right now is unstructured data, and that is the you can say nowadays we always say that okay, now data is a new oil. So if we are not going to mine it, we are not going to get anything out of it. So basically, if we are mining the data, so we are going to get new insights out of it. But the data that we are generating is mainly the unstructured data. And again, handling this unstructured data with the traditional systems was not a option, because it was not able to do it properly. Even with structured data, after a after a particular threshold, let me talk about exact data or tera data. After 20 terabytes of volume, they just say okay, I'm not able to process it. So the performance is getting delayed a lot. So at that point of time, basically these were the issues. So now variety means like we are getting the data from audios, videos, images, weblogs, and sensor data. These all data that we are getting, except some of the data, some part of the data, let's say around minimum 1 to 5% of the data that we are generating right now is in structured format. Rest of the 90 to 95% of the data that we are generating is in the unstructured format. So and that is the main data that we have to mine it, process it, and then we'll get the insight of it, right? Nowadays, like if you want to understand the psychology of a person, and if you have get, let's say, last 2 years of chat with you, so you will be able to understand a particular person, what kind of a person he or she is, right? So this is the power of the data that we are having. So nowadays, like a lot of even the psychologists, they always try to study the human behavior from the data itself, from the data points that they are gathering. So initially, IBM has come up with the definition of big data with three V's, but then they have come up with another V, like veracity. Veracity is the uncertainty in the data, basically the correctness in the data itself, right? So sometimes what you are going to get, let's say you have got a lot of data for some years, but for some years or some data points are missing. So again, handling those kind of data was a bit difficult task for the traditional systems. Then, but handling such data with the uh, this Hadoop technology was easier. So basically, when they've started with three V's, so whatever be the problems that the traditional system were facing, those were taken as the definition of big data. So initially they have started with three V's, but then they have come up with another V called veracity, and now they have come up with another V, which is called as you know another V is called value. and this is one of the important V nowadays. Value means like whatever data we are processing, whether from that data are we able to generate the value out of it. If we are not generating the value, then what is the use of doing this whole process? So that's why value is a crucial factor in deciding what do you mean by big data. Now, so now we have got 5 V's are there. So generally we define in terms of 5 V's. Other V's are also there, but till now we have got the, like, if we talk about the definition of big data, so generally these 5 V's we specify: volume, velocity, variety, veracity, and the value. Understood? Now, as I told you, like, there are a number of scenarios are there where this uh, big data is playing a very crucial role. So let's say, as I told you, we are having some e-commerce sites are there. So it can be eBay, Amazon, or let's say Flipkart, or other eBay, electronic business websites are there where customers are going. So basically what they are trying to do is, like, they give the recommendations. So for that they have built the recommendation engines, and recommendation engines basically giving, like, based on the choice of the person, they are always going to give similar kind of products. Ads are going to be there, as the the data is growing so large. So when we have got the huge amount of data is there, so basically the search quality is also going to be increased, right? Apart from this, like, with this, the introduction of big data, these lot of fraud detections are getting they are being stopped in advance before it's getting that the fraud used to happen earlier. Now the frauds are they are getting stopped before happening because of this big data. Because nowadays, like, what happens is, with the help of this data analysis itself, a lot of things, the banks or the the organizations, they get to know in advance that, okay, these scenarios are they are going beyond the edge cases, so that they just come up with some sort of precautions, and based on that they stop a lot of these frauds. But still the frauds are happening because the frauders are, they are also very smart people. They are techies, good techies, and they always target those peoples who are not familiar with those kind of latest the latest scams they have come up with. So big data is really playing a good role. Apart from this, like, if you can go to any of the the any of the domain where this big data is playing a very good role. So there are a number of different scenarios, customer scenarios are there. So nowadays, like, with the help of this big data, you can just book your tickets online. Everything is getting settled, and with the introduction of AI, also AI agents, you don't have to do any sort of pre any sort of you don't have to plan anything. Everything will be done by the AI agents itself. So yeah, if we talk about, like, how they are working, so they are working because of this big data, because they have got the data. So they got trained on huge and huge amount of data, like billions and trillions of data points they have got trained, and based on that they have trained on different scenarios. Why they are able to do that? Because we have got those data points are available with us. So how much data the model is going to get trained, it will be more better results it should provide. So based on that, it is how this is happening. Apart from this, like, there is another telecommunication uh, scenarios are there where telecom organizations, they they make the use of this big data and try to reduce the their network failures, churn preventions, and CDRs are getting analysis are getting used in in most of the criminal cases are nowadays CDR data is getting used by the investigating officers to actually get the the longitude and latitudes where the particular person was there at the time of the incident happened. So these things are really playing a very good role in forming the big society and a good society itself. Okay, so here I just wanted to give you a study. At that point of time, it was done in 2005. So at that point of time, when the introduction of internet was there and a lot of people were switching, so new things were coming up. At the same point of time, basically, there when the people was thinking, okay, now the data is going to flooded, and what is going to happen in next let's say 10 years or 20 years from now, what will be the size of the data and how it is going to impact whether our traditional systems, like at that point of time, whatever the systems were there, are these systems will be capable enough to handle this huge surge in the data itself. So for testing this, this share corporation did some study on that, and what they did is preview whatever the the size of the data that they were working upon. They tried it with 100 to 1,000 times of same data and tried to test it on the existing systems like SAS, Oracle's Teradata, Exadata, and Teradata. So these are very good players. Like Teradata can handle up to 20 terabytes of data. So instead of terabytes, they have tested it on them petabytes of data. Like, because as the volume of the data is getting increased, it's getting added exponentially. So they want to do a thorough study on this, like after 5 to 10 years down the line, what is going to happen with the data, and if this data is going to be exploded in this exponential manner, whether our systems will be capable of handle such huge surge in the data itself. So they did this study and they find it out that CS Corporation find out, like, okay, these traditional systems were not able to process this huge amount of data. But when they did the same study on the Hadoop itself, so if you see this elephant, so this is the logo of Hadoop. So they were able to do it. Like, even there was no problem. What traditional systems got failed to process it, the same data in terms of petabytes, 2 petabytes of data that they took for their study, 300 node cluster of Hadoop, it was able to do it in some time itself, right? So what was the issue that they were facing at that point of time? Basically, what is happening is, like, traditional systems used to have two different layers are there. Basically, they have got the storage layer and they have got the processing layer. So storage layer means like where we are processing our data, we are storing our data, and processing layer is the one where we have to process the data, so we have to move the data. So there are two different layers, right? So we have to move the data. So first thing, if you see, like instrumental, so these are the different sources, then we are collecting those sources data and putting into a storage grid layer. So you can take it as some sort of data warehouse where we are putting the data. From warehouse to, we are moving to using some ETL process, we are moving the data to compute grid where we are processing it, right? So this Teradata, Exadata, SAS, these were the the ETL process that we used to use to process this huge amount of data. So from storage to ETL grid, when we were moving this data, right? So we were having these mainly these three issues that were prevailing, mostly. The first thing was we cannot explore high fidelity raw data. Means for processing, whatever data we have at the source side, similar data we are not getting at the processing side, because when we are processing this huge 2 petabytes of huge amount of data, so there might be the case during processing some of the data may get corrupted. Sometimes we see like when somebody, I'm sending a message or I got message from someone, it's some few kbs or even mbs of data got corrupted over the network, right? Because we are sending it over the network. So but when we are sending the data in terms of this huge and huge amount of data, so there are n number of issues, like network bandwidth can be the issue, network can be a issue, and other issues can be there which can hamper this data. Another issue was like, let's say I was processing this, sending this 2 petabytes of data, but for the ETL, we have just got only 10% of the data. I got it was available for the BI. Rest of the data, maybe because of network bandwidth, I was not able to get it. It got lost in transition. But let's say I got 90%, even 10% of my data got lost. Even that is a huge data, right? 2 petabytes of data. Even I'm losing just 1 GB of data, if I'm processing something and I get to inside of it. So that can also play a very crucial role in deciding something. Third one is the premature data death. Premature data death basically happens because of the cost, right? Like using traditional systems, we cannot store everything. Why? Because we have got the storage limitations on those parts, because these are traditional systems are very expensive systems, and if we are going to store huge data, we have to maintain that infrastructure with us also. So that is coming up with the cost itself. So what we used to do at that point of time, like after a certain point of time, we used to delete that data, right? Let's say if I talk about the hospital data, so previously we used to store only last 7 years of data, and once the data is older than 7 years, it's automatically go to my archiving system, and after some point of time it automatically got deleted, right? So these were the three main issues. Cannot explore high fidelity raw data, it means you are not getting the same data. The moving the data that does not scale mean we are not getting the same amount of data for the processing. And the third one is the premature data, right? Like because of the storage limitation on the server itself, we cannot hold all the historical data for my processing. So automatically it used to get deleted. And now like patient data is how much it's crucial. Like it doesn't mean like after 7 years of data, we let's say if I have to analyze last 20 years or 30 years of cases, like what happened at that point of time, if those cases can help the present doctors to analyze the situation, and based on that they come up with some sort of treatment. But if we don't have that data, then how the current doctors will get to know all those things? So those were the limitations with that. So these were the limitations on the traditional systems. Any questions, any queries over this?
नो सर, आई थिंक ये जो जितनी भी लिमिटेशंस हैं ये सब हडूप ओवरलुक कर देगा इसको, है ना?
Exactly, definitely. So ये तो होता ही है ना कि जो whatever limitations we are going to have, if we are not able, if new system is not able to handle all those ones, then definitely that is not a good system, right? So
यस.
we always try to build whenever a new system is coming, so that should overcome all the existing issues. So how it had handled by the Hadoop itself. So you see, the problem is like when we are moving the data from one layer to the another layer. So how Hadoop had resolved it? So resolved it, Hadoop has done it. Okay, this is the problem with the moving the data. So if I'm not moving my data, don't you think this is going to resolve my issue? So in Hadoop, what we are doing is whatever.
So I have one question.
Yeah, yeah.
Actually, sir, हम लोग जो भी स्टार्ट करेंगे विद द हडूप वी स्टार्टेड द टॉपिक जो हमारा रहेगा फर्स्ट वो हडूप ही रहेगा देन पाइथन से स्टार्ट करेंगे हम लोग आफ्टर 2 सेक्शन.
No. After 2 sessions, we'll be starting with Databricks, Spark, जो
Okay.
अभी चल रहा है. But you have to understand these things. क्योंकि यहाँ से भी sometimes when you are sitting for the interviews, they try to understand what is the knowledge that you are having. So sometimes the questions are not directly going to be asked, but indirectly they ask these questions, right? And if you don't understand the like how it was started, because even my Spark architecture is based on my Hadoop architecture. The only thing is in Hadoop we are we were processing through the disk, and in Spark we are only processing, everything is getting processed in the RAM itself. So that's why that is faster, right? We'll talk about this, right?
Okay, sir.
Yeah. So how Hadoop has resolved this? So Hadoop says, okay, whatever, wherever I'm storing my data, I'm not moving my data at all to another location. What I will do is I'm going to process it here itself, right? So I'll move my processing, not the storage. Now think about, like, I have got petabytes of data, but what is going to be my processing? If I have to do some sort of processing on it, this data, it can be in KBs, it can be in MBs. It never go to GBs. Have you ever seen, like, you have written a some processing code and it is in gigabytes? It will never. You are going to write some code, let's say in 1,000 line, 10,000 lines of code, or it may, if it's going to be quite complex, it can be in some few 100,000 lines of code, right? And that can be in some MBs itself, right? Even if I'm writing, let's say, PySpark code, I have written, let's say, 5 to 10,000 lines of code I'm writing right now. So if I talk about that notebook sizes, it is still in some MBs only. If I'm just removing the all the shell outputs. If I talk about the code itself, right? So it's not going to it's not that much large, right? And if I remove these extra data or extra statements out from that notebook itself, right? So again, like, if I have to move my data, let's say MBs of data and petabytes of data, so which is going to be easier? MBs of data. So that's why instead of moving my storage, I'm just bringing my storage, bringing my compute to my storage itself. So when I'm processing at the same layer where my data is there, then there is no going to be no, you are not going to have any sort of issues with your data. So first, your data exploration and advanced analytics, all the data is available for that purpose. There is no issue with this scalability. When I'm not moving anything, then definitely whatever data I'm having at the storage layer, it will always remain intact. And the third point is no data archiving. Why? Because here we are going to add as many number of systems we can have in the form of nodes itself. Node means one system. So basically here let's say I have started with the 100 node cluster and I want to add more machines, so I can add more number of machines: 100, 200, 500, 12,000, even 15,000, 20,000. So 12,000 node cluster, 20,000 node clusters, they have already been tested, and there is nothing causing any issues so far, right? So in Hadoop, this storage or data live forever is going to be, let's say I need 100 GB storage. So I have, let's say, 100 GB storage. So I have got, let's say, 5 node cluster is there, or let's say 500 GB storage, 5 node cluster is there. On each machine I am having 100 GB storage, right? Tomorrow I want 2 terabytes of storage. So accordingly, I am going to create, let's say, 100 node. I have created a 100 node cluster. So after some point of time, let's say 5 years down the line, I need to use 2 petabytes of storage. So I can have, let's say, 200, 300, 400, 500 node cluster. So it depends on what kind of systems that I'm using. So Shears, what they did is, like, they moved to a 300 node Hadoop cluster, and they were able to keep their 100% data available for processing, rather than which was 10% available in case of non Hadoop solutions. Understood? Now we are only trying to understand here. Hadoop had resolved it, but how they have resolved it will come to that point, right?
Yes.
Okay. So till here, any questions?
No, sir.
Okay. Now, so Hadoop cluster, basically Hadoop uses this DFS, technology, this methodology that they are using. DFS is distributed file system. So instead of processing or storing the data on one machine, we are going to process it or store it on multiple machines. So they have just given an example. If I'm processing something from a machine which is having a read speed of 100 MBs per second, having 4 input output channels, and similar kind of machines which can read 100 MBs data per second and having 4 input output channels, I am working with 10 machines. So if I have to read it 1 terabyte of data, so one machine is taking around 43 minutes, and we are taking, okay, it's not, it's running simultaneously continuously, and there was no failure at all, right? So it is taking around 43 minutes. But the same task, if I'm doing from 10 machines parallelly, then how much time it is going to take? Definitely 4.3 minutes, right?
Yes.
Now, so basically Hadoop, what is Hadoop? So Hadoop is basically a framework that allows for processing my data in distributed manner. Means I'm going to process the data in parallel from multiple machines, and also going to store my data onto those machines, not as single machine, across clusters of commodity computers. Now here, the term this.
Like same data Hadoop hold करता है different machines में, या like chunk of data hold करता है?
So basically, first try to understand this. Commodity computers means these are cheap hardwares, low cost hardware, right? And using a simple programming model. Simple programming model means it uses MapReduce. What is MapReduce we'll understand later, but now you can think about the simple programming model that it uses. It's a MapReduce. MapReduce terminology that we are using for processing the Hadoop cluster, right? So Hadoop एक framework है which is processing and storing your data in a distributed fashion, and processing the data in using MapReduce from commodity of computers, right? अब जो commodity of computers, as I told you, it's cheap hardware. अब हमने कहा cheap hardware है, so basically cheap hardware, so it is prone to down, कभी भी down हो सकता है, right? So for that reason, Hadoop uses replication factor of 3 by default. जो भी मेरा data, whatever data I'm having on one machine, similar data is going to be replicated to 2 other machines also, right?
Okay.
Yeah. So if my machine is going to be down, one machine is down, I can get the data from another machine. If 2 machines are down, I can get the data from the third machine. And all the 3 machines are down at the same point of time. This is very rare because we can have these machines on the same data center or onto different data centers. 2 can be on the same, third one is on different issues. So it might be the case like, okay, if my data center is down, my whole data center is down, still I can get the data from the another data center, right?
Yes.
This is how it works. Now it is an open source data management because it was, started from the Apache itself, and it was their open source project, and then they have just, donated it to the community, and it's now this uses scale out storage mechanism and distributed processing, as we have distributed means parallel processing from multiple systems. Now there are two things again. One is this scale out mechanism. Scale out storage. And another one is we used to have is scaling. Scaling mechanism. So first understand what is scaling. Scaling में क्या होता है कि हमारा we have got some RAM, some hard disk is there, and some chipset is there, motherboard is there, which is processing this. So after some point of time, if I need to have some sort of storage, I can add one more disk to this system. Right? I can add some more RAM to the system, but this will go up to certain limit, right? Because this chipset doesn't allow more of the modifications. It should not be the case like I have started with, let's say, 1 TB storage. I have started with 1 TB storage and let's say 120 GB RAM, 128 GB RAM. And I can go up to, let's say, 5 to 10 terabytes only, right? But it should not be that I have to go to, if let's say 100 terabytes. So it is not going to work because my chipset is not going to work. Same for RAM. Let's say I've started with 128 GB RAM and I can go to up to 256 GB. But after that, my chipset is not going to be, because if I have to remove, replace everything, what I can do is I can get another machine, another server. But again, these server costs are quite high, right? It's in, 100,000 in terms of 100,000 pounds or dollars that we have to, spend to get a server itself. So this is my scale, means like scale in or scale vertical also we called it as. Like we can increase the configuration up to a certain limit, but after that limit, it's not going to allow. But in scale out mechanism, what happens is that, let's say initially I've started with 10 machines. I need 10 more, I can add 10 more. Or I need 100, I can 100. I need 1,000, I can add 1,000 in the same cluster itself. I just need to add the number of machines, restart my cluster, so it will be able to realize this. And here, each machine, this machine as it's a commodity hardware, its storage as well as processing are there, right? So if I'm increasing the number of machines, automatically my processing as well as my storage is going to be getting increased. Understood? So this is the difference between scale out and scale in mechanism. This is a very important concept, right? So what happens here is today I need only 100 node cluster, so I can work with 100 node cluster. Tomorrow, let's say 1,000 node cluster, so I can add according to my requirements.
Scale out.
These are the key characteristics of my Hadoop, right? We have understood most of them. So if I ask you why I'm saying Hadoop is economical, even though I'm using more machines, because I have to do the replications, right? Like whatever data I'm having at one machine, similar data I also need to have on 2 other machines, right? But still it is economical. Why it is economical? Because we are using commodity hardware, right? I'm writing it as CH. My writing is not good, so CH, commodity hardware. Because of it is using commodity hardware, it is economical. In comparison to, we are going to buy, a cluster itself, right? A server. If I have to choose between a server and a Hadoop cluster, so Hadoop cluster is always going to be cheaper, right? Then scalable. Scalable, as I told you, why it is scalable? Because of storage scale out mechanism, right?
Yes.
Or scale horizontal. You can say scale horizontal. It is scalable. Whenever we want to add more machines, we can scale it. Flexible, as Hadoop can adopt multiple data formats or new complexities which are getting introduced, is always allow them to process. So uh, our traditional systems only process structured or up to some level semi-structured data sets, but Hadoop can process structured, semi-structured, unstructured. And if any new format is coming to the system, we are able to accommodate it, right?
Yes.
And the last point is reliable. Why we are saying it's reliable? Hmm?
Due to its scale out,
No, scale out means scalability.
we can hold same data with different
Yes,
machines.
yes, yes. Reliability means like here we are maintaining the replication factor. So it's fault tolerant, right? Like
Yes.
my machine is one machine is down, I can get the data process the data on another machine. So it's fault tolerant. So because of this fault tolerance, it's more reliable, right? So these are the Hadoop design principles. Like it facilitates and storage processing of large and complex and rapidly growing data sets. So those can be structured or unstructured data using simple programming model, which is MapReduce. It is uses scale out rather than scale up mechanism. Main point here is also we are bringing data to code to the data rather than data to the code. So in traditional systems, what we were doing is we were bringing data to the code. So wherever my code was there, I was sending my data to the code itself, and sending data to the code, it was expensive, as well as the issues that we have faced. But when we are just moving our code to the data, as my code size is very less, it is going to be faster, as well as cheaper, as well as it's safe, right? So because of this, we are getting higher scalability. Like whenever we want, we can add more number of machines, and that's why it will always be available because of its fault tolerance. Use commodity hardware. It is my data is always available because even if my system is going to be down, one system is down, two systems are down, I can get it from the third system itself. So it's just fault tolerance, right? So any questions, any queries so far on this? Because these are the some of the things that you need to understand, right?
Not yet, sir.
Okay, fine. So now these are some of the differences that we have to understand between RDBMS and RDBMS means traditional systems, because all the traditional systems were mainly the RDBMS, whether it's going to be any of the SQL Server, Oracle, Exadata, Teradata, they all RDBMS. So if we talk about what are the data types that they can work upon, so RDBMS, we know that mostly it's going to be the structured, or some level up to like they can work on like some work can work on XML, so that is semi-structured data sets also, or some JSON formats can be worked upon, but not directly. For that we have to tweak something, right? Then Hadoop can work on multiple data types, or it can be structured, semi-structured, unstructured, any kind of data you are going to bring it, whether it's going to be audio, video, images, all can be processed, right? Then when it comes to processing, so we have say, okay, limited in the sense like no data processing means like, here we have got, certain limitations on the data that it can process. As I told you, up to 20 terabytes of data it can process by exadata or teradata. But once this limit is achieved, so it start, degrading its performance. It doesn't mean that it's not going to process it, yeah, but some failures can be there that it will give you sometimes, the slowing down of the process can be there. But in Hadoop, that my process coupled with the data itself. So whenever we want, we can add more number of machines. So parallelly, we can process it and store more data. Governance in RDBMS, they are already structured and standards are defined. But in Hadoop, this is loosely structured, means like if something is new is coming, so it can accommodate all those things. So that's why it's loosely structured. The next point is required schema required on write, and in Hadoop it's required on read. So what do you understand by this? Required on read is like you have worked in in RDBMS, right? So tell me one thing. How do you insert your data in a table? Like when you can insert your data in a table?
Sorry.
How like when if you have to insert, let's say I have given you 100 records and you have to insert that data in a particular table. So how you are going to insert those records?
Using query SQL.
Yeah, SQL query will write insert in table name values, right?
Yes.
But will how you are going to ensure that you should not get any error while inserting the data? How you are going to ensure this? What will be your
Checking the data again using query select.
but select query where? Unless you have not inserted the data, how you are going to make the select on that table? First you have to insert the data, right? Only then
Yes.
you are going to do a
Check the data.
select on that, right?
Yes.
And to insert the data, you have to validate its schema, right?
Yes.
So first, I'm going to create a table. Within the table, what are going to be the columns? What and the column data type itself, and their the size or the range of data that they can hold, right? Only then, like let's say I'm having a table and I've created a table with two columns, ID and name. So ID I have specified as some integer, and names are going to be my some strings are there, right? And then I've created table, and now when I'm inserting it, so I'm writing 1 comma Raj, right? 2 comma Yash. But instead of this, if I'm insert into table name values in ID, I'm just putting Raj, and in name I'm putting, let's say, 123. Will it allow?
No.
Why? Because we have, when we are writing the data RDBMS, we have to validate it first, right?
Yes.
So before even writing the data, we need schema validation on write. So this is a required on write, right?
Yes.
But in Hadoop, what we are doing is like when we are storing the data, we are not checking anything. We are just dumping the data, right? So in the warehouse itself or data lake, right, nowadays, what we do is we are not checking anything. Whatever data is coming, like in what format, the data is coming in diverse data sources, like it's coming in CSV, it's coming in JSON, it's coming in Parquet format, it's coming in Excel formats, it's coming in even database format, YXDB formats, multiple data formats that we are coming. We are just dumping it. We are not checking at anything, what kind of data that we are working on it. But when we are reading the data, at that point of time, we are defining what data exactly we are reading. So that's why in Hadoop, The schema validation is required when we are reading it. And why it is so? Because in Hadoop, we are dealing with terabytes and petabytes of data. And when the data coming as a raw format, there might be the chances the data is having some sort of noise, some bad data is there, some corrupted data is there. So if we are just checking it at runtime only, then we will never be able to write the data into the Hadoop, right? Because every time the data is coming is different. Every time the data is coming, some issue is there with the data, right?
Yes.
So when we are processing the data, reading means when we are processing the data, at that point of time, I'm checking, okay, whether I'm getting the correct data. If that data is correct, then it will allow it. Otherwise, it will either it is going to, based on our requirement, we are going to fail the job, or we are going to, remove that bad data or quarantine that data. It's all based on our requirements, right?
Yes.
Understood these points, because these are really required, right?
Yes.
Important
Yes.
points to understand. Okay. So because based on this, if we talk about the speed, so that's why the in RDBMS reads are going to be the fast, because when we are reading it at that point of time, it's not uh, you know uh, it
We
is not
don't have to validate the data.
it's not going to validate the data, because हमने already write के time पे validate कर रखा, तो
Yes. Yes.
reads fast हो जाएंगे. Hadoop में उल्टा है, क्योंकि हमारे राइट्स फास्ट है, क्योंकि राइट्स में हमारा कोई वैलिडेशन नहीं है, राइट? वी आर सो स्पीड, इसीलिए हमारा जब रीड करते हैं तो देन इट माइट बी द केस दैट रीड्स आर फास्ट इन केस ऑफ आरडीबीएमएस, बट वो भी तभी होगा व्हेन वी आर वर्किंग ऑन स्मॉलर डेटा सेट्स. लेट्स से अगर
Yes.
मैं टेराबाइट्स पेटाबाइट्स पे काम करता हूँ, तो इवन जो हमारा आरडीबीएमएस है, दैट इज गोइंग टू बी लिटिल, it's not going to have that much of capacity, because Hadoop में क्या है कि we are reading it in parallel, but RDBMS में हम parallelly read नहीं कर रहे ना. That is going to be some sort of sequential. एक मशीन होगी या दो हो सकती है, एक से ज्यादा, ठीक है ना?
Yes.
बट Hadoop में तो हम 100,000 machines के साथ parallelly read कर रहे हैं, so it cannot. Let's say let me give you an example. मेरा I have a server, ठीक है ना, उसका let's say 10 टेराबाइट स्टोरेज है और 512 GB रैम है. सो आई एम प्रोसेसिंग इट, सो इट विल, लेट्स से अगर मैं 100 MB या फिर 1 GB की बात करता हूँ, एंड आई एम हैविंग लेट्स से 100 node cluster on Hadoop, so it might be the case कि 1 GB of data is RDBMS is going to read it faster, right? But when it comes to let's say 1 terabyte of data, so Hadoop is going to read it faster, right?
Yes.
Then comes the cost. So every RDBMS had some sort of software licenses are required. कोई भी हो, even if I talk about Postgres or even MySQL. If you are just taking the MySQL for, although it's open source, if you are taking it for production issues or for business purpose, then you have to take the license, right? But Hadoop it's totally open source. If you want, you can pay for some sort of support only for support, but it's going to be very minimal charges are going to be there for that. Then in RDBMS there are already known entities are there, but Hadoop on daily basis new things are coming up, new growing complexities are there. Nowadays you see like in data engineering, a lot of new things are coming, complexities are coming, and they are able to accommodate all those things. Then which one we have to use where? So RDBMS is basically mainly used for OLTP, online transaction processing, where we have basic transactions, banking transactions are there. So there still we are using RDBMS, but Hadoop is mainly for the historical data, where we have to do some discovery, analysis, OLAP kind of data, online analytical processing are there. Last 10 years, 20 years, 50 years of data I need to process, right?
Yes.
That I'm going to use this. So on these points, any questions, any queries so far?
No, no, sir.
Okay. So now you're fine till now, right?
Uh,
Okay.
yes,
So
sir.
let's have a 2 minutes break. Let me have some water.
Yes,
Then
yes.
we can
No
start.
issue.
Yeah. Okay. Fine. So basically, now we are going to understand Hadoop ecosystem, right? So here we have two things, Hadoop 1.0 and 2.0. So we have mainly worked on 2.0, and still if organizations are using, so those are using Hadoop 2.0 only, right? So if you see at the at the bottom, we have got Flume and Scoop are there. So these were the two tools that were getting used at that point of time for bringing our data from our different sources to the HDFS. So in Hadoop, basically we have got HDFS, Hadoop distributed file system, where we are going to store the data. So it's a file system. uh, how we are going to store the data. So Hadoop is as the name specifies, distributed file system. My data is going to be stored in distributed fashion. It's not going to be stored on a single machine. It will be there on multiple machines, right? And the data is going to be stored in the form of blocks. So default block size in Hadoop 1.0 was 64 MB. So let's say if my file is 1 GB, so 1 GB file is going to be distributed to 16 different blocks. So 1024 MB divided by 64 MB. So that is the default, but we can make it to like it was configurable. We can make it to 128, even to 256. So these Scoop and the Flume are the tools which brings my data from different data sources to HDFS. So Scoop is only for structured data, and as the two arrows are there, so it can bring and bring in and bring out the data
Okay.
using Scoop. But Flume is only used to bring the unstructured data or semi-structured data from diverse data sources, like we are getting the like some tweets from the Twitter, or some messages from Instagram, Facebook, or anything. Mainly the unstructured data that we are getting, we can put it into the HDFS. So HDFS is my storage layer, right?
Okay.
Hadoop distributed file system. And top of it, we have got this MapReduce framework, as I told you, which is used for processing it, right? So
Okay.
initially, this MapReduce framework is written in Java. So we used to write the mapper and reducer code in Java, and then for processing part, right? On this itself, we have got HBase. HBase is a NoSQL database. If you have any idea on the NoSQL databases, are basically the not only SQL database, like RDBMS is work on structured data sets, but NoSQL databases mainly are the works on not only SQL databases. So they have got their different storage mechanisms. Like RDBMS generally stores the data in the raw format, but NoSQL database can store their data in the columnar format. So which is a lot of optimization techniques or optimizations on top of it, so that storage is better, as well as when we are processing it, when we are selecting the column, so it reduces a lot of latency, and because of that it's more faster. So on top of MapReduce framework, we have got Hive data warehouse system. So Hive is a warehouse system where which mainly used for processing data analysis, and it is similar to SQL, language. Hive is almost similar to SQL. So like selects are from table name, similar selects are from table name. We do Hive also, right? Similar, very very little, few differences are there, but if you say 90%, more than 90%, it's same what we are doing as a part of SQL. And Hive was introduced because of this only, because the people who were working in the move to this Hadoop or big data technologies, they were previously working in the RDBMS itself, so they were mainly familiar with this SQL. So moving from SQL to MapReduce, it was a very difficult task for them. So for those people who were not feeling comfortable or doing the MapReduce programming, so for them it was given as like a data warehouse system. Hive was introduced, but there was one limitation with Hive, was that it was not able to process unstructured data sets. It can process structured as well as semi-structured data sets, but not unstructured like audio and video files. So there we have to use the MapReduce, and once we have converted our code data from unstructured to semi-structured, then we can use Hive. So basically for conversion in between, most of the people, they used to write MapReduce code, and once they are done with it, so they generally for data analysis, processing, warehousing concepts, they go back to Hive. So it's not the case that you have to use only one technique in the system itself. You can use multiple ones. Then we have got Pig Latin. It's a data analysis language which is English-like language. So, but right now nobody is using it, because we have got other good languages are there, because it had some sort of limitations on top of it. But yeah, it was also used for data analysis. Pig Latin. Then Mahout was machine learning library was there, which at that point of time used to, like, if I have to do some sort of machine learning models I have to use. So using Mahout library, it was easy to call some of the inbuilt functionalities that for that we don't have to use write the code, specific code. We just need to call those libraries. So it was very beneficial at that point of time. And on top of it, it is Apache Uzi was there, which was a workflow to orchestrate everything. Like whatever we are doing, we have to specify like how these things will going to work, how I'm going to load the data, then store it. Everything is going to be, like how many number of jobs are going to be. So that thing, like orchestration part, was done by this workflow itself, right?
Yes, sir.
So when we in Hadoop 1.0, it was going fine, but what happens is, like, when the companies were working on Hadoop 1.0, it was going fine, but when they have tested the data for more than 4,500 or 4,000 clusters of data, till the cluster size was 4,000, it was working fine. But what they've seen is, like, when they were going beyond 4,000 node cluster, so they start identifying or seeing some sort of performance issues within the system itself, right? So then they identified it and find it out that MapReduce was getting overburdened, because what the MapReduce was doing is, like, MapReduce was it's a programming paradigm which was used for processing, right? So with processing also, MapReduce code was also doing the cluster management, like how the cluster is going to work, how many number of workers are going to be there, how many number of nodes it's required. So cluster management plus code processing of my data. This was being done by the MapReduce framework in Hadoop 1.0. So when the data size was increased and the people were start using more than 4,000 node clusters, so they start seeing this performance issues. So they have come up with Hadoop 2.0, where most of the things that you are going to see the same. The only difference is they have come up with this YARN, yet another resource negotiator, that is, which was used as a cluster resource management. So YARN's duty was to, do the cluster resource management, and the only task of my MapReduce was to process the data. So when this task was taken up by the YARN itself, the company has tested for 12,000 data nodes, and there was no lag, there was no issue with the performance itself, right? So apart from this, the rest of everything was same. Like the only thing was, like in Hadoop 2.0, the default block size was increased from 64 to 128 MB. And why it has been increased, we'll talk about, right? Rest of the things are same, and they have also added few more, frameworks like MPI. MPI is message passing interface. So like whenever we are working with, let's say Facebook, Twitter, Instagram. So there, if we have to analyze those messages, so we have to write some custom code for that. But in Hadoop 2.0, they have come up with this framework. Like I have to process some messages, so I can directly call this API, MPI, and I was able to process it. So again, it reduces the human efforts. Then graph, like whenever we are working on graph technologies like networking and all projects. So there, this graph plays a vital role. So how it need to identify the nodes and how many number of links are going to be there, those kind of things. So that also reduce a lot of burden. Rest of the things are same. Understood? So any questions, any queries so far? So basically in Hadoop 1.0 and 2.0, the main difference was this addition of cluster resource management, which reduce the burden on the MapReduce framework. So in Hadoop 2.0, the only task of MapReduce just to process the data.
Yes.
The resource management was taken up by the YARN itself, right? And
Yes.
another major difference was this addition of framework, and the default block size increased from 64 to 128 MB, right?
Okay. Not more than 128 MB.
No. It is configurable. Default.
Okay.
What if you are not changing it, if you are not making any changes to the configuration, so it will always be divide. Let's say I have just loaded my 1 GB file, so it is going to be distributed into 8 blocks, and it's going to store on the cluster itself. It can be on 2
Okay.
machines, it can be on 4 machines, it can be on 8 machines, right?
Okay.
Yeah, depending on the availability, right? Let's say if I'm having let's say I'm having just one node cluster, so everything is going to be stored on my one machine, although it is divided into because for processing it has divided into blocks itself, and it is going to process from the single machine. But if I'm having, let's say, 10 node cluster, so it might be the case that my 8 blocks are they have split it across 8 different machines, right? So based on the availability, it will take. So these are the Hadoop core components are going to be there. As I told you, one is storage and another one is the processing, right? So in HDFS is mainly used for storage and for processing. As now in Hadoop 2.0, it's YARN, which is used for processing, right?
Yes.
So these are the 4 you can say threads, or we call it as daemons, right? Daemons means services. So these are the services are there. So for storage, two services, name node and data node. For processing, two services, resource manager and node manager. And now within these two, as my Hadoop is a it's a master slave architecture. So there are two masters are there and two slaves are there. These are the main services that we are running, right? So for storage, name node is the master, and for processing, resource manager is the master. For storage, data node is the slave, and for processing, node manager is the slave, right? Understood?
Yes.
Now you have to understand the communication between them. So my storage and processing, both masters can talk to each other. Like name node can talk to resource manager, slaves can talk to each other, data node can talk to node manager, and master and slave for the storage, they can also talk to each other. My name node can talk to data node. Same, resource manager can talk to node manager, but their cross communication is not allowed. What does it mean? It means that this communication is not allowed, right? My node manager cannot talk to directly to resource manager. My name node cannot talk to
Node manager.
they will talk, but how they will talk? Like if something needs to be processed, so name node will go to resource manager, and resource manager will talk to this. This will respond back to this, and this will respond back to this. Likewise, if this has to talk to this, so this will talk to this. This node manager will get the details from this back and return back to this, and this will return back to this for processing, right? This is how it is going to happen. So both masters can talk to each other, both slaves can talk to each other, storage related master and slave can talk to each other, both the daemons, master and slave, processing related master slave can talk to each other, but my name node cannot talk to node manager, resource manager cannot talk to data node, right?
Yes.
So this is how it happens, right? Same configurations. Now, as I told you, my name node is going to be the main, let's say within an organization, we have got the owner, right? So owner has got, more power. It is the main core of the system, or you can say the CEO of an organization, right? So it's similar to, like, for example, it's a Lamborghini car, which is very expensive, right? And it has got a lot of features are going to be there, right? But the CEO of an organization cannot do everything, right? When it goes to, like, when we are talking about the name node, so name node is the master of the system, and it only holds the metadata, right? Holds the metadata of the data nodes. Like, let's say I've got a 10 node cluster, so my name node is holding all the information on those data nodes. Data nodes, we are saying it here as machines, right? You can think of that, because these are the threads are there which are running on my machines. These are the services basically. So data node runs on the slave machine or the commodity hardware, right? While my name node work on the my high-end architecture. So it's similar to very good machine, which is not going to be down very easily, right? But we know, like, even servers prone to down, right? हम सुनते हैं ना, जैसे कभी बैंक में गए हो, स्पेशली गवर्नमेंट बैंक, जब भी जाओ कहते हैं सर्वर डाउन है। भाई यार, कैसे सर्वर है तुम्हारा? हमेशा ही डाउन रहता है मोस्ट ऑफ द टाइम्स। मेरे साथ तो एसबीआई में यही हुआ है, जब भी जाओ,
स्पेशली पंजाब नेशनल बैंक।
मेरे साथ एसबीआई, मेरा पंजाब नेशनल में तो मेरा अकाउंट नहीं है, बट एसबीआई में व्हेनेवर आई गो टू, भीड़ लगी होती है, पूछो उनसे क्या हुआ, सर सर्वर डाउन है। मैंने कहा यार तुम्हारा ही सर्वर डाउन होता है, मुझे समझ में नहीं आता, सर्वर अच्छे वाले सर्वर ले लेते।
गवर्नमेंट नहीं देती ना पैसा उन बेचारों को।
नहीं, ऐसा नहीं है राज, मेरा भी 10-15 साल हो गए अकाउंट है यार एसबीआई में, मेरे को तो 1-2 बार ही मिला होगा।
अरे भाई आप गुड़गांव में रहते हो ना, मेट्रो सिटी।
ये सही है।
PNB में out of 365 days you can say 260 days उनका सर्वर डाउन ही रहता
बन डाउन ही रहता
है। मैनेजर बनो तो PNB के
है।
चिल्लाई है।
एग्जैक्टली। सो वही है, बट नेम नोड का यहाँ पे काम क्या है कि इट्स ओनली मेंटेन्स द द डेटा ऑन दी लाइक मेटा डेटा ऑन दी लाइक हाउ मेनी नंबर ऑफ ब्लॉक्स आर देयर। एक पर्टिकुलर मेरा डेटा नोड में व्हाट इज दी how many number of blocks are available on each machine, how many out of those blocks, how many blocks are free, how many are captured, occupied. So those information remains with the name node. So that's why जो हमारा नेम नोड है इट इज हैविंग वेरी गुड रैम होने का भी इसका रीजन है, बट इट डजंट हैव टू स्टोर द ह्यूज अमाउंट ऑफ डेटा, सो इट डजंट नीड टू हैव लार्जर रोम स्टोरेज। इसको ज्यादा रखने की जरूरत नहीं है, बट एक्चुअल स्टोरेज गोइंग टू बी हैपन ऑन माय डेटा नोड्स। लाइक अगर हम टैक्सी की बात करते हैं, ठीक है ना, तो अगर देखें तो जो टैक्सी है दे आर द मेन कम्यूटर्स जो कि मैक्सिमम पैसेंजर्स को लेके जा रही है। अब लैम्बोर्गिनी सबके पास तो हो नहीं सकती है, और लैम्बोर्गिनी में जाएगा भी तो एक या दो बंदा मैक्सिमम। टैक्सी में आप 10 लोगों को घुसा लो। ओके, सिमिलर वे डेटा नोड्स का क्या काम है? जस्ट टू स्टोर द मैक्सिमम डेटा दे कैन होल्ड। प्रोसेसिंग करेंगे पैरेलल, सो दैट्स व्हाई ऑन ईच ऑफ द डेटा नोड, जो हमारा डेटा नोड है वो स्लेव्स मशीन्स पे होता है, एंड they have got the actual storage and process is going to be done on these machines itself. So they are mainly responsible for read and write requests, right? So जो भी हमारा डेटा आएगा वो हमारा डेटा नोड्स के ऊपर ही रीड एंड राइट होगा। मेन जो डेटा है, फाइनल डेटा, लेट्स से अगर मुझे 1 terabyte डेटा स्टोर करना है, so that data is not going to be stored on my name node, that is going to be stored on my data node on the cluster itself. But वो 1 terabyte डेटा कहाँ किस मशीन पे कितने ब्लॉक्स में डिवाइड होके कहाँ गया है, दैट इंफॉर्मेशन रिमेन्स विद द नेम नोड इटसेल्फ, राइट? क्योंकि वो एक मशीन पे तो होगा नहीं, तो एक डेटा नोड के ऊपर कितना डेटा है वो उस डेटा नोड को तो पता है, बट हर डेटा नोड पे क्या डेटा है वो मेरे नेम नोड को पता है। अंडरस्टूड? क्लियर है?
यस यस।
हाँ, तो बेसिकली अब नेम नोड में जो हमारा डेटा है ये मेन मेमोरी में यानी कि रैम में ही रखते हैं, तो दैट्स व्हाई इट हैज गॉट गुड रैम। और उसका रीजन है क्योंकि अगर हमारा डेटा रैम में रहेगा, सो एवरी टाइम इट इज I'm just I need let's say okay I want to process this particular file, so I'll resource manager will go to name node और पूछेगा कि भाई मुझे इस फाइल पे प्रोसेस करना है तो मुझे इस फाइल का डेटा दे दो। So if that data is already there in the RAM itself, name node immediately will pass on this file. Okay, this is the metadata for this particular file, and this data contains is divided into these number of blocks, और ये blocks मेरे इस मशीन पे हैं। जैसे ये देखोगे ना, user doc hinfo, so hinfo file is 135, यानी कि हम just here we are just taking 1 2 3 numbers, but in actuality अगर हम नेटवर्क की बात करते हैं, so there we have got machine IP addresses होते हैं, ठीक है ना, which specify the uniqueness of a machine. So यहाँ पे हम just for the understanding ये करें 135, यानी कि मशीन 1 3 5 पे हमारा hinfo है, 2 4 और 2 पे p details है, pdd, ठीक है। These files are stored in these files. So similar way यहाँ पे इन्होंने फाइल्स की फॉर्म में दिया है जस्ट टू मेक यू अंडरस्टैंड, बट इन एक्चुअलिटी द डेटा इज डिवाइडेड इनटू इन द फॉर्म ऑफ ब्लॉक्स, राइट? कि मेरी एक फाइल का जो ब्लॉक है वो ये ब्लॉक यहाँ पे इस फाइल बेसिकली मशीन पे रिटन है, राइट? सो अब टाइप ऑफ डेटा, मेटा डेटा क्या है? लिस्ट ऑफ फाइल्स, कितने फाइल्स हैं, कितने ब्लॉक्स हैं ईच फाइल में, और जो लिस्ट ऑफ डेटा नोड्स ऑन ईच ब्लॉक, file attributes, access time, replication time, creation time, and number of metadata is there that is being stored on the name node itself. तो अगर ये main memory में होगा then it will be easily like immediately available. But अगर मेरा name node में space नहीं है, it doesn't have that much of RAM, so what it has to do is it is going to store the same data in its hard disk. So hard disk में होगा, so basically then it will go and find that data in the hard disk itself to bring it into the main memory, और अगर ऐसे उसे करना पड़ेगा, this is called demand paging. Like if you are demanding that page which was not there in the memory itself. So that's why we always try to have the more RAM on name node, so that it should always have all the data in the RAM itself. So if anytime we want that details, metadata from the name node, so it will immediately give us. Otherwise it will go to the to the hard disk, get that details and then fetch it. So there are going to be file system metadata ke liye it has to do the demanding of the page. But if we are having everything is there in the metadata itself, so no demand paging is there. Understood? Apart from this, it also have got transaction logs के हमारा file creation, file deletion, as I told you, updation कितना हुआ, कितने records delete हुए, update हुए, वो सारी information हमारा name node पे रहती है, right? Now another question was why default size block size increased from 128 MB to 64, from 64 to 128 MB. So take the example, अगर मेरा 200 MB की file है, so Hadoop 2.0 में we are only going to have 2 blocks, but in Hadoop 1.0 4 blocks. This is just for 200 MB, right? So अगर I am having 4 blocks of size, so definitely जो हमारा मेन वो है basically first thing is seek time. Seek time means like searching from the 4 blocks or searching from the 2 blocks. Which one is going to be easier? 2 blocks, so it will be faster. Another, we are also having the the limit on the size of the name node. So अगर हमारा block का size कम होगा तो हमारे नंबर ऑफ ब्लॉक्स ज्यादा बनेंगे. नंबर ऑफ ब्लॉक्स ज्यादा बनेंगे तो उसका मेटा डेटा भी ज्यादा होगा. मेटा डेटा ज्यादा होगा तो मेटा डेटा को स्टोर करने के लिए रैम भी ज्यादा चाहिए होगी. And as the RAM is costlier, so thinking on that direction, it has been mentioned. And also, like if you want, we can also make it to even 256 MB also, right? But keeping both the things in, like, because agar block ka size bhi jaya hota, sometimes it can when we are processing it, so agar block ka size zyada hoga aur utni RAM kisi machine pe available nahi hai, memory available nahi hai, so that is going to impact it, wo bahut zyada time le lega. So keeping all the things in time, it was decided that okay, this is going to be the optimal solution. So that's why still we are keeping 128 MB as the default one. Still अभी हमारा कोई भी सिस्टम है उसमें हमारा डिफॉल्ट ब्लॉक साइज इज 128 MB. कोई भी, चाहे हम कोई भी इवन क्लाउड भी कोई भी यूज कर रहे हैं, आइदर वी आर यूजिंग AWS, GCP, Azure, everywhere by default the block size is 128 MB. Right? Understood? Both the points? Yes? Yes? No?
Yes.
हाँ देखो बोलते रहो, नहीं तो मुझे लगता है सो तो नहीं गए.
नहीं सर.
नहीं बता देना अगर नींद आ रही हो तो. देखो
नहीं.
देखो मुझे तो नींद नहीं आएगी क्योंकि मुझे बोलना है, जिसको बोलना होता है उसे नींद नहीं आती है, बट जिसको सुनना होता है उसे नींद आ जाती है, लेकिन मुझे भी आ जाती है. ठीक है, तो अगर लगे तो वी कैन हैव सम ब्रेक, राइट? ओके, नेक्स्ट जो मैंने बताया था आपको, रेप्लिकेशन फैक्टर एंड रैक अवेयरनेस पॉलिसी, लाइक why these 3 replications are there and what is the use of those replications. So let's suppose simple example से समझते हैं. 3 ब्लॉक है हमारे ABC and these are 3 racks. Racks क्या होते हैं basically? If you have seen any of the data center pictures or have you ever been to any of the data centers? मुझे नहीं लगता गए होगे क्योंकि it's very rare to कोई मतलब nobody is allowed to go to that. मैंने भी सिर्फ data centers को picture में ही देखा है क्योंकि I've never got the chance to go to a data center. हाँ, जो मतलब I mean to data center for BSNL, जो उनके अपने data centers. So similar kind of data centers we have. So basically racks होते हैं, उन racks के अंदर machines होती हैं. Here we are just having 4 machines, but in actual data centers you can have to 16 to 24 machines in one rack. So 1, 2, 3, 4, 1, 2, 3, 4. These are the machines, 5, 6, 7. So these are the numberings we have given, but in the real scenario, as I told you, those are going to have the IP addresses. अब हमें 3 blocks को store करना है in particular racks में. So as I told you, जो rack 1, 2 or 3 है, they can be on the same data center, or they can be on 2 different data centers, or they can be on 3 different data centers. तीनों के अपने अपने pros and cons है. So अगर if I'm saying okay, तीनों एक ही they are on the same data center, so it's going to be faster and cheaper. क्योंकि एक ही डेटा सेंटर पे, सो व्हेन आई एम गोइंग टू स्टोर द डेटा ऑन लेट्स से रैक 1, उसका रेप्लिकेशन भी वहीं पर है और सेकंड रेप्लिकेशन भी वहीं पर है. तो जो नेटवर्क बैंडविड्थ है दैट इज गोइंग टू बी नॉट दैट मच और इजी हो जाएगा, राइट? बट मेरा एक डेटा सेंटर लेट्स से रैक 1 एंड रैक 2 ऑन माय वन डेटा सेंटर, रैक 3 ऑन, सो rack 1 to rack 2 is easy क्योंकि वो same data center, but rack 2 to rack 3 we have to make some sort of like switch बनाना पड़ेगा. यहाँ पे एक switch होगा which is going to talk to these machines, और फिर उस data को यहाँ से ये यहाँ से इससे बात करेगा, फिर ये इसके से बात करेगा, and then finally going to write it. Likewise इस तरह से communication होगा, right? But from here to here, it will need some sort of network bandwidth and to move the data and all, right? But this is safer in the sense that, let's suppose at some point of time, if my this rack is down, then I can get the data from this down, this one, right? But if in case this my whole data center is down, so I can get the data from this one. But in first case, if all 3 are on the same data center, if my whole data center is down, so I lost my all data, right? Understood?
Yes.
So ये सुनामी के टाइम पे हुआ था जब जापान में एक पूरा का पूरा सुनामी आई थी ना, तो एक पूरा डेटा सेंटर और पूरा खत्म हो गया था. But they have got like they are Japanese, so they always put the data into multiple data centers. So they didn't lost any data, but yeah, they lost the whole data center, right? During tsunami. So at like from that incident, even those who used to have only all the data on the single data center, now they have moved to at least to 2 locations, right? Now the third case is ये तीनों data center ही मेरे तीनों different locations, right? So अगर मेरा ये data center भी loss हो गया और let's say there is some issue with this data center, I can get the data from this one. If यहाँ पे भी कोई issue आ गया तो I can get it at the third one. और ये तो बहुत rare बात हो गई कि तीनों ही जगह गड़बड़ है, right? So in that case we can't do anything. But this is also configurable. This is default कि आप 3 racks में data 3 replication रख सकते हो. But replication again can be 4 and 5 also, right? It depends on your use case to use case.
Yes.
Okay, so now what I'm going to do is like how we are going to replicate them. So let's say हमने block A को पहले rack A की number 1 machine पे डाल दिया, तो इसकी जो replications आएंगी those are going to be at rack 2, 5 and 6. So why we are putting it 5 and 6? क्योंकि 5 और 6 बिल्कुल close है दोनों machines. So moving from this to this needs some sort of network. But जैसे ही हमने 5th पे replication किया, 5th to 6th replication is going to be rack local, right? So ये faster होगा. That's why we are doing it. So we always do it in this way कि हमारा first जो copy होगी वो एक machine पे होगी और दूसरी जो replications करेंगे generally we used to do it on the another rack, but both the replications on the same rack. So this is faster approach, but it's not always going to be optimal based on your requirement, right? But it is cheaper and faster, same way. Although we can do it like rack 1, rack 2 or rack 3 में तीनों में हमें एक replications दे सकते. So that's all depends on our use case also, right? Because these racks can be on the same data center, they can be on the different data center, 2 can be on the same, and third can be on the different one. Likewise, any case can be possible, right? बेस्ड ऑन आवर रिक्वायरमेंट्स। अब फिर आता है कि हम रीड राइट ऑपरेशंस कैसे करते हैं। तो अगर हम बात करते हैं कि हम डेटा को राइट कैसे कर रहे हैं, सो द अप्रोच इज कि इफ आई हैव टू राइट द डेटा फर्स्ट, लेट्स डू सम हाउ वी आर गोइंग टू राइट इट, राइट। सो पहले राइट करने के लिए एज आई टोल्ड यू, द क्लाइंट विल सेंड अ रिक्वेस्ट, और वो रिक्वेस्ट किसके पास जाएगी? नेम नोड के पास जाएगी, बिकॉज नेम नोड हैज गॉट ऑल दी इंफॉर्मेशन अबाउट दी क्लस्टर, कि हमारा जो क्लस्टर है उस क्लस्टर में कितने मशीन्स हैं, कितने मशीन्स में कितनी मशीन्स अप है, कितनी डाउन है। बिकॉज क्लस्टर में जो हमारी मशीन्स है वो तो हमारी कमोडिटी हार्डवेयर है ना, तो हो सकता है कि 100 नोड क्लस्टर में 4 मशीन डाउन हो, सो वी आर हैविंग ओनली 96 नोड्स अप, और उन 96 नोड्स में लेट्स से 50 मशीन्स पे मेरा स्पेस बहुत ज्यादा अवेलेबल है, बाकी सब पे इतना ज्यादा नहीं है, या प्रोसेसिंग चल रही है या राइटिंग का काम चल रहा है, डेटा इज गेटिंग रिटन। क्योंकि अब सिर्फ एक ही टास्क तो हो नहीं रहा होगा, देयर आर गोइंग टू बी मल्टीपल जॉब्स आर रनिंग, तो कुछ रीड कर रही होंगी, कुछ राइट कर रही होंगी, बट वी आर फर्स्ट थिंग वी आर डूइंग, ओके हमारी तो पहली जॉब है, सो दैट्स व्हाई वी आर जस्ट सो एचडीएफएस क्लाइंट जो होगा, इट विल गिव अ रिक्वेस्ट टू नेम नोड कि भाई मेरे को लेट्स से 1 GB की फाइल है, तो इस 1 GB की फाइल को मुझे स्टोर करना है क्लस्टर पे। सो नेम नोड विल गेट दी, बिकॉज नेम नोड के पास एक स्नैपशॉट होता है, और स्नैपशॉट में सारी डिटेल्स होती हैं, लाइव डिटेल्स, कि किस पर्टिकुलर नोड पे क्या चल रहा है, कितने नोड्स अवेलेबल हैं, कितने फ्री हैं, कितने ऑक्यूपाइड हैं, ऑल दिस इंफॉर्मेशन इज विद द नेम नोड। सो नेम नोड get this information and creates one job. Then name node sends this information, basically this metadata, to the client, or client, once the client get this metadata, then it will directly going to contact to the data node itself. तो वो डेटा नोड के पास जाता है और कहता है कि भाई ठीक है, ये मैं यहाँ तुम्हारे पास अवेलेबल है, इस ब्लॉक को तुम अपने पास राइट करो। सो जैसे ये राइट करता है डेटा नोड, देन ये तो हुआ हमारा पहला फर्स्ट राइट। अब जैसे ये राइट करेगा तो 2 रेप्लिकेशन भी तो चाहिए ना, तो ये डेटा नोड इट विल लुक फॉर इट्स नेबर्स, क्योंकि इस डेटा नोड के पास सारे जितने भी डेटा नोड है, they can talk to each other, as I told you, all the data nodes can talk to each other, right? तो yes. ये डेटा नोड देखेगा कि इसके आसपास वाला कौन सा है, बिकॉज वाला देखेगा तो उस पे नेटवर्क का भी बैंडविड्थ का इम्पैक्ट आएगा, तो राइट करने में थोड़ा टाइम लग सकता है। सो इट विल ऑलवेज चेक फॉर द नियरेस्ट नेबर, कि उस नियरेस्ट नेबर के पास स्पेस अवेलेबल है, तो कहता है ठीक है भाई, ये वाला डेटा तुम, ये जो मैंने एप्लीकेशन दी है इसको राइट करो। फिर ये क्या करेगा, नेक्स्ट वाला ये देगा, और इसके बाद नेक्स्ट पे चला जाएगा। जैसे ये तीसरा राइट होता है, ये एक्नॉलेजमेंट उसको वापस देता है कि भाई हाँ ठीक है, मैंने ये डेटा अपने पे लिख दिया। ये क्या कहेगा अच्छा मैंने अपना और तुम्हारा दोनों का डेटा, और ये तीसरा उसको बोलेगा कि जैसे कि मशीन 1, 2 and 3 है, ये बोलेगा कि मैंने खुद पे भी लिखा और 2 और 3 पे मेरी इसकी रेप्लिकेशन है, और इस एक्नॉलेजमेंट को बैक वापस सेंड कर देगा इसको एचडीएफएस, और एचडीएफएस भी सेंड करेगा, और नेम नोड को भी ये क्या करता है, डेटा नोड हर आफ्टर सम पॉइंट ऑफ टाइम इट सेंड्स एक्नॉलेजमेंट, और वी कैन से हार्टबीट टू नेम नोड आल्सो, कि भाई नेम नोड को बताता है कि आई एम डन, आई एम फाइन, आई एम वर्किंग फाइन। क्योंकि नेम नोड को कैसे पता चलेगा कि भाई ये पर्टिकुलर डेटा नोड करेक्टली काम कर रहा है नहीं कर रहा, तो ये डेटा नोड इसको नेम नोड को भेजते हैं हार्टबीट, और एक सर्टेन पॉइंट टाइम तक ये नेम नोड को अगर कोई हार्ट बीट नहीं मिलती, तो नेम नोड कहता है कि ओके ये पर्टिकुलर जो डेटा नोड है ये डाउन हो गया है, तो उस पर्टिकुलर डेटा नोड पे जो भी डेटा था उसको वो दूसरी जगह पे रेप्लिकेट कर देता है, ठीक है ना। दिस इज हाउ इट वर्क्स, राइट। सो इन दिस वे द क्लाइंट गेट्स द बेसिकली कि मेरी जो फाइल थी 1 GB की फाइल, वो 8 ब्लॉक्स में डिवाइड है, और 8 ब्लॉक्स में कहाँ है सारी इंफॉर्मेशन मेरी नेम नोड पर स्टोर हो जाती है। और क्लाइंट का काम क्या था, राइट किया, राइट करने के बाद उसने अपने आप को किल कर दिया, राइट, इसका काम यहाँ पे खत्म हो गया। नाउ इट कम्स टू कि हमने जो डेटा स्टोर किया है इसको कहीं प्रोसेस भी तो करेंगे ना कभी, तो प्रोसेस करने के लिए भी हमारा सेम प्रोसेस है। द ओनली थिंग इज कि अब यहाँ पे जो हमारा एचडीएफएस क्लाइंट है, उसको चाहिए अब वो प्रोसेस किस पे करेगा? अगर मेरा डेटा जाएगा तो प्रोसेस पहले क्लाइंट क्या करेगा? क्लाइंट किसके पास जाएगा? हमारा जाएगा। अब इंस्टेड ऑफ गोइंग ऑन दी नेम नोड डायरेक्टली, इट विल गो टू दी रिसोर्स मैनेजर, ठीक है ना? रिसोर्स मैनेजर के पास जाएगा। अब रिसोर्स मैनेजर के पास वो जो फाइल है जो आपने अभी स्टोर करी थी, उस फाइल का मेटा डेटा तो है नहीं, उसको कैसे पता है कि मुझे कहाँ प्रोसेसिंग भेजनी है? So what it will do is it will go to resource manager can talk to name node, वो name node के पास जाएगा, बोलेगा कि यार ये जो abc.txt फाइल थी, मुझे इसको प्रोसेस करना है, तो मुझे इसकी ब्लॉक लोकेशंस चाहिए। तो name node अपने उसमें देखेगा, मेमोरी में चेक करेगा, मिलेगा, और वो सारी जो भी मेटाडेटा फाइल थी उसकी मेटाडेटा वो उसको रिटर्न कर देगा। ब्लॉक लोकेशंस का मतलब मेटाडेटा, राइट? वो उस मेटाडेटा फाइल को रिटर्न करेगा रिसोर्स मैनेजर को। रिसोर्स मैनेजर, अब जैसे ही वो रिसोर्स मैनेजर के पास आती है तो नाउ रिसोर्स मैनेजर नो के ओके ये जो फाइल है ये इस पर्टिकुलर डेटा नोड पे है। तो हर एक डेटा नोड पे हमारा नोड मैनेजर भी होता है। अब जो हमारा रिसोर्स मैनेजर है, इट कैन नॉट टॉक टू डेटा नोड डायरेक्टली,
Yes.
इट विल सेंड दैट इंफॉर्मेशन टू, क्योंकि उसको पता चल गया कि इस डेटा नोड पे ये हमारा ब्लॉक ऑफ डेटा है। तो उन हर एक जहाँ पे हमारा वो डेटा स्टोर्ड है उन सबको भेजता है वो कि भाई ये मेरे को डेटा प्रोसेस करना है। तो वहां का जो नोड मैनेजर है वो लेता है और फिर वो उससे बात करता है डेटा नोड से कि भाई ये वाली इन फाइल से मुझे प्रोसेसिंग करना है। ऑल्दो जो हमारा डेटा है उसकी 3 रेप्लिकेशंस होती हैं, बट मेरी जो प्रोसेसिंग है वो सिर्फ एक पे होती है। ये डिफरेंस, ठीक है ना?
Yes.
जैसे प्रोसेसिंग मेरी एक पे ही होगी, 3 रेप्लिकेशंस है, बट मेरी प्रोसेसिंग एक पे होगी। हाँ, अगर वो डेटा नोड या नोड मैनेजर डाउन हो जाता है तो फिर अगेन जो नोड मैनेजर है, जैसे डेटा नोड मैनेजर को भेजता है हार्ट बीट, वैसे ही मेरा नोड मैनेजर रिसोर्स मैनेजर को भेजता है। तो जब तक रिसोर्स मैनेजर के पास हार्ट बीट आता रहता है, उसको लगता रहता है कि ये काम प्रोसेस हो रहा है, चल रहा है। अगर उसको भी सर्टेन नंबर ऑफ टाइम्स अगर वो हार्ट बीट नहीं मिलता तो नेम नोड को ये लगता है कि उसको रिसोर्स मैनेजर को लगता है कि भाई ये तो नोड मैनेजर है, डाउन हो गया। तो उसके पास अभी 2 एप्लीकेशंस तो हैं, उसे पता है कि इसके अलावा 2 जगह और है मेरा डेटा, तो वो सेम टास्क किसी दूसरे नोड मैनेजर को भी असाइन कर देता है, राइट? तो यहाँ पे एक कॉन्सेप्ट आता है स्पेक्युलेटिव एग्जीक्यूशन। वो क्या है कि समटाइम्स ऐसा होगा कि जो मेरा नोड मैनेजर है ना वो डाउन नहीं है, इट वाज बिजी विद डूइंग सम अदर टास्क, ठीक है ना? उसके पास कुछ और भी टास्क थे, तो वो अभी आपका जो टास्क था वो पाइपलाइन में है, बट उस पर्टिकुलर टास्क के लिए वो रिसोर्स मैनेजर को वो नहीं भेज नहीं पा रहा है हार्ट बीट। तो उस केस में क्या करता है कि वो सेम टास्क किसी दूसरे को असाइन कर देता है। तो जब उसने दूसरे को असाइन किया, उसने उस पर प्रोसेसिंग करनी शुरू करी, और ड्यूरिंग दिस टाइम आल्सो इधर ये भी फ्री हो गया, तो इसने भी प्रोसेसिंग करना शुरू कर दिया। तो जो सेम ब्लॉक की प्रोसेसिंग थी, ब्लॉक ऑफ डेटा की प्रोसेसिंग थी, वो 2 नोड्स पे साइमल्टेनियसली चल रहा है, राइट? अंडरस्टूड?
Yes.
जैसे कि रीड 4 रीड 5 ये दोनों एक ही काम कर रहे हैं, लेट्स सपोज, मतलब ये भी उसी पे काम कर रहा है, ये भी उसी ब्लॉक पे काम कर रहा है, दोनों जो रीड 4 रीड 5 ऐसे समझ लो। तो दोनों में से जो भी पहले कंप्लीट करेगा दैट विल अपडेट दैट रिजल्ट कि मैंने ये कर लिया, मेरा काम कंप्लीट हो गया, तो दूसरा ऑटोमेटिकली उसको किल कर देता है, ठीक है ना? तो ये जो प्रोसेस है, इस प्रोसेस को हम बोलते हैं स्पेक्युलेटिव एग्जीक्यूशन। ये क्वेश्चन पूछ लिया जाता है कि कभी कभी क्या होता है, एक से ज्यादा सेम जो ब्लॉक ऑफ डेटा की प्रोसेसिंग is happening by the multiple node managers at the same point of time. So out of those two, whosoever wins first, it updates the result back to the resource manager, और इस process को हम बोलते हैं speculative execution, right?
Yes. Yes, sir.
Understood है ना?
Yes.
चलो, तो ये बेसिकली दिस इज हाउ आई टोल्ड यू, लाइक ये पूरा प्रोसेस है हमारा बेसिकली कि हमारा रीड एंड राइट ऑपरेशंस कैसे होते हैं। तो अब ये तुम्हारे ना दिमाग में रहना चाहिए कि back of the mind every time whenever we are going to do any sort of read करेंगे, हमने कोई कमांड लिखी है तो बैकग्राउंड में हमारा यही सब होगा, ठीक है ना, ये सारी चीजें हमारी बैकग्राउंड में चलेंगी, ठीक है।
ठीक है।
So Hadoop के डिस्ट्रीब्यूशंस की हमें जरूरत नहीं है, बट व्हेन वी यूज्ड टू वर्क ऑन Hadoop डिस्ट्रीब्यूशन, Hadoop ने क्या किया था, पहले दो काम होते, या तो हम अपना खुद का क्लस्टर बनाए, ठीक है ना, तो क्लस्टर बनाने के लिए हमारे पास एक क्लस्टर बनाएंगे, उसमें कितने मशीन्स बनाएंगे, फिर ये इंस्टॉल करो वो इंस्टॉल करो। तो क्लाउड एरा हॉटवर्क मैपर ने क्या किया, हमें एक डिस्ट्रीब्यूशन बना के दे दिया, ठीक है ना। तो उसमें क्या होता है कि यहाँ से हम डायरेक्टली अपने सर्वर पे और उनकी जो कॉन्फ़िगरेशन फाइल्स होती हैं उनके थ्रू हम उनको कनेक्ट कर सकते हैं अपने क्लाइंट मशीन से, और क्लाइंट मशीन पे हम ये अपना CDH इंस्टॉल करके हम डायरेक्टली कैन कनेक्ट विद द क्लस्टर इट्सेल्फ। सो इसकी वजह से चीजें बहुत आसान हो गई थी, ठीक है ना। Now, as we are not going to work on this, so we don't need this. Otherwise, I have got this, CDH के मेरे पास पड़ा हुआ है. Now it's paid. Previously it was free. क्या होता था, ये 8 GB का होता था, and now it's around 20 GBs. Still, some of the organizations are using, Cloudera, Hortonworks, or Mapr. These are the three main organizations. So Cloudera का market is almost 60%, right?
Okay.
ठीक है. So this was all about our, first like what was this and that. So अभी हम कर सकते हैं ना, ऐसा तो नहीं एग्जॉस्ट हो गया
कल की, और बाकी कल करे तो बेटर है क्योंकि मैं एक्चुअली क्या मैं हाँ मैं दोबारा ये वीडियो दोबारा देखूंगा, देन क्रिएट सम नोट्स फॉर माय सेल्फ।
हाँ ठीक है, बट अभी थोड़ा सा मैं बता देता हूँ आपको कुछ जो कल नहीं, थोड़ा सा आर्किटेक्चर डिस्कस करेंगे, बट अभी मैं आपको थोड़ा सा बता देता हूँ। So we don't have to repeat few things, right? ये हम बात कर ही चुके हैं, ठीक है ना। सो इसमें क्या है कि ये क्लस्टर का मैं तुम्हें एक एग्जांपल दिखा देता हूँ। तो टिपिकल क्लस्टर कैसे होता है, तो क्लस्टर में हमारा एक होता है एक्टिव नेम नोड, ठीक है, एक होता है स्टैंड बाय नेम नोड और एक होता है सेकेंडरी नेम नोड। तो ये सेकेंडरी नेम नोड जो है ये ऑप्शनल है हमारा Hadoop 2.0 में, बट 1.x में इट वाज मैंडेटरी, राइट? Because in Hadoop 2.0 we have got the concept of this standby name node, but Hadoop 1 में standby name node का concept नहीं था। तो ये देखो ना, हमारा जो name node है वो काफी high end machine है, RAM 64 GB, हालांकि ये तो बहुत पुराना है। Now in RAM generally we are having 128 to 256 to 512, हार्ड डिस्क जनरली हमारा 1 टेराबाइट का मिलेगा, हाई एंड प्रोसेसर्स होंगे। बट अगर हम डेटा नोड की बात करें तो हमारे सिंपल सिस्टम्स होते हैं, जैसे कि हमारा कमोडिटी हार्डवेयर रैम 16 GB है, बट हार्ड डिस्क देखो 6 स्टोरेज है ऑफ ईच ऑफ 2 टेराबाइट, सो हमारा ऑलमोस्ट 12 टेराबाइट्स है एक मशीन पे, राइट? सो दीज आर ऑलमोस्ट ऑल कमोडिटी हार्डवेयर। सो द कॉन्सेप्ट ऑफ स्टैंड बाय इज देयर। तो होता क्या था कि बेसिकली अगर मैं Hadoop 1 की बात करूं तो वहाँ पे सेकेंडरी नेम नोड होता था। तो सेकेंडरी नेम नोड क्या करता था, एवरी 1 आवर इट यूज्ड टू टेक द बैकअप ऑफ माय एक्टिव नेम नोड, राइट? जैसे कि 10 बजे लिया, फिर 11 बजे लिया, फिर 12 बजे लिया, ठीक है। तो अब क्या होता है कि होता क्या था कि अगर मेरी एक्टिव नेम नोड डाउन है तो व्हाटएवर डेटा दैट वी हैव, अब तो वो हम वहां से सेकेंडरी नेम नोड से बैकअप कर लेते थे एंड देन विल स्टार्ट वर्किंग ऑन दैट। बट उसमें क्या इशू क्या है कि लेट सपोज मैंने 10 बजे स्टार्ट किया, ठीक है, 10 बजे मैंने बैकअप लिया, नेम नोड का बैकअप मेरा 10 मिनट का है, उसके बाद 1 घंटे हमने प्रोसेसिंग करी, उसमें कुछ डिलीट किया, इंसर्ट किया, अपडेट किया, जो भी रहा, ठीक है ना, कुछ डेटा आया, कुछ डेटा गया, कुछ प्रोसेस हुआ, और उन सारी प्रोसेसिंग का जो अपडेशंस हुई वो सारी डेटा नोड्स में हो गई हमारी, ठीक है। अब लेट सपोज 10:50 पे मेरा एक्टिव नेम नोड डाउन हो गया, तो जब मैं चेक करूंगा डेटा को तो आई कैन ओनली हैव डेटा टिल 10 AM। अब 10 AM से 10:50 AM तक 50 मिनट में जो भी कुछ हुआ, कितने कोई डेटा नोड डाउन हुई या अप हुई, डेटा राइट हुआ, कुछ डेटा डिलीट हुआ, अपडेट हुआ, क्योंकि प्रोसेसिंग के बाद अपडेशन वगैरह जो भी हुआ वो डेटा है ही नहीं इसके पास, ठीक है ना।
हाँ
तो वी हैव लॉस्ट दैट डेटा, तो हमें पहले 1 घंटे से स्टार्ट करना पड़ेगा, 10 बजे से। 50 मिनट का हमें पता नहीं क्या हुआ सिस्टम में, कुछ नहीं पता। सो टू अवॉइड दिस थिंग, Hadoop 2 में दे हैव कम अप विद दिस स्टैंड बाय नेम नोड। तो स्टैंड बाय नेम नोड का क्या होता है कि स्टैंड बाय नेम नोड की जो कॉन्फ़िगरेशन है वो सेम होती है। सेकेंडरी नेम नोड की सेम भी हो सकती है और कम भी हो सकती है, बट एक्टिव नेम नोड और स्टैंड बाय का सेम रहेगा। क्यों? तो होता क्या है कि जो मेरा एक्टिव नेम नोड में हो रहा है, इसके ऊपर हम क्या करते हैं, यहाँ पे एक शेयर्ड एडिट लॉग करके एक फाइल होती है। तो जो भी हमारा एक्टिव नेम नोड में हो रहा है वो हमारा उस एडिट लॉग फाइल में जाता रहता है, और वो एडिट लॉग फाइल हमारी रन टाइम पे इज शेयर्ड बाय स्टैंड बाय नेम नोड। तो अगर कभी भी मेरी एक्टिव नेम नोड डाउन होती है तो एट द सेम पॉइंट ऑफ टाइम विद इन ए फ्रैक्शन ऑफ सेकेंड स्टैंड बाय नेम नोड टेक्स ओवर इट एज एक्टिव नेम नोड। तो इसलिए हमारा ये ऑप्शनल है, ठीक है। अब ऐसा तो है नहीं कि ये बहुत जल्दी जल्दी डाउन होगी, ठीक है। एक बार मेरा एक्टिव नेम नोड डाउन हो गया तो, क्योंकि हाई एंड आर्किटेक्चर है तो इजीली डाउन होता नहीं है, बट as वी हैव ऑलरेडी डिस्कस्ड, सर्वर्स आर प्रोन टू डाउन, राइट। तो डाउन तो हो सकता है, राइट। तो यही है वही पूरा। अभी हम देखा क्लाइंट है तो HDFS अगर स्टोरेज के लिए जाएगा तो नेम नोड के पास जाएगा, नेम नोड डेटा नोड के पास जाएगा, और अगर उन्हें प्रोसेस करना है तो नेम डेटा नोड से नोड मैनेजर के पास जा सकते हैं। प्रोसेसिंग के लिए source manager to node manager to data node. This is how the the communication happens, right? इसके अलावा Hadoop 2 में there is one more federation architecture was there कि भाई अगर फ्यूचर में कुछ ऐसा हुआ कि हमारा डेटा इतना बढ़ गया, इतना ज्यादा बढ़ गया कि एक नेम नोड के पास इतना प्रोसेसिंग पावर नहीं है, स्टोरेज वो नहीं कर सकता, मेटा डेटा को स्टोर नहीं कर सकता, तो वी कैन हैव द मल्टीपल नेम नोड कॉन्सेप्ट also, right? So name node one for, let's say, HR, finance, healthcare data, something like this, right? This is tried and tested concept, but अभी तक कोई यूज नहीं कर पाया क्योंकि उतना डेटा हुआ ही नहीं किसी पर्टिकुलर नेम नोड का, because 1 terabyte is a huge, it's a like huge data. और अगर हम नेम नोड की भी बात करते हैं, अगर रैम की बात करते हैं, तो even right now name nodes can have up to 512 GBs of RAM. तो 512 GB RAM, और जो metadata है, like for one file which is having, let's say, 1 GB 1 terabyte of data, 1 terabyte data को अगर मैं metadata की फॉर्म में करूँ तो it will have some KBs of data only, right?
yes divided by 60
right, क्योंकि उसमें तो सिर्फ हमारा metadata ही तो रखना है, बाकी तो कुछ की जरूरत है नहीं, ठीक है। So this is tried and tested, और ये मैंने अभी आपको हाई अवेलेबिलिटी आर्किटेक्चर बताया था भाई कि एक्टिव नेम नोड है, शेयर्ड एडिट लॉग्स है, स्टैंड बाय नेम नोड। सो इफ माय एक्टिव नेम नोड इज डाउन एट एनी पॉइंट ऑफ टाइम, सो दिस स्टैंड बाय नेम नोड टेक्स ओवर एज एक्टिव नेम नोड। सो इसमें हमें सेकेंडरी नेम नोड की जरूरत नहीं है। सेकेंडरी नेम नोड एक्ट एज ए होल्ड बैकअप, बट माय स्टैंड बाय नेम नोड इज द कॉन्सेप्ट। सो अभी समटाइम्स ऐसा होता है कि हम कंफ्यूज कर जाते हैं सेकेंडरी नेम नोड, स्टैंड बाय नेम नोड। सो बोथ आर डिफरेंट कॉन्सेप्ट्स, राइट? Yeah, so basically this is what we have already discussed कि कैसे resource manager से। So okay, I'm stopping it here क्योंकि इसमें मुझे अभी आपको मास्टर वगैरह ये सब बताना है। Then we'll discuss further। हमने जो आज सीखा है उसको थोड़ा सा और डीप डाइव करेंगे कि एक्चुअली में हमारी जो फाइल्स हैं वो कैसे मूव करती हैं, ठीक है ना। ये तो एग्जांपल है, ठीक है। ये कुछ Hadoop में कॉन्फ़िगरेशन फाइल होती है, बेस्ड ऑन दीज फाइल्स ओनली हम अपना पूरा जो क्लस्टर है उसको डिफाइन कर सकते हैं, ठीक है ना। यहीं पे हम डिफाइन करते हैं कि हमारे मास्टर्स कौन से हैं, स्लेव्स कौन से हैं, मैं राइट, जो मैं आपको बता रहा था कि क्लस्टर के बेसिस पे सब कुछ काम चलता है, ठीक है।
yes
तो अगर अभी जो भी हमने डिस्कस किया है, इफ एनीथिंग यू नीड any sort of clarification, just go through it first. Tomorrow we can have all those questions from your side and then we'll discuss, right?
yes
So आज का और कल का भी थोड़ा सा मतलब I took it little faster, ठीक है। तो अगर कहीं पे कोई कॉन्सेप्ट तुम्हें लगा कि हाँ अभी समझ नहीं आया तो you can ask me, right?
definitely
Okay, right. Okay. Any questions, any queries, please let me know.
Not now. I'll see that video again.
ठीक है. Okay, fine.